Today, what is our point of discussion is that operations on the dependent variable. So the third operation is the modulus. So first two operations that amplitude scaling and amplitude reversal that we have already dealt with an example. So you guys will have a good idea over that. So here the dependent variable means the major thing you guys have to remember is that dependent variable is x of t. So x of t, which will be generally consider that will be the vertical axis. So that's why all the dependent variable operations will be mostly with respect to the vertical axis. So here if you see the modulus, how the modulus can be calculated for the signal is that the process is very simple. So here the portion of graph above horizontal axis kept as it is. The portion of graph or portion of signal. So the portion of signal above horizontal axis will be kept as it is. So below horizontal axis. So below horizontal axis, just a mirror image. So below will be mirror image with respect to horizontal axis. Okay. So this is what the simple definition. So let me draw one diagram so that you guys can able to understand it visually. So signals and system as network theory, I'm parallel, I'm taking that subject also. So network theory, everything we need to analyze with the help of graph. Here in the signal system, everything we have to analyze with the help of network theory, everything we need to analyze with the help of circuit. So here we everything we need to analyze with the respect to graphs. So that's what graph means, the signals. Okay, so let me draw like this. So here I'm taking some square waves. Okay, so this is the way. Let me name it some functions. So this is -1, so this is 1, so this is 2, so this is t, and this is x of t. Okay, so if we find out the modulus, so how the modulus will be looking is that, so the graph part which are above the horizontal axis means this triangle will be as it is. So there won't be any change in the triangle part. So below part, right? So this one considers negative value. So here if you say this one is -1, this one is 2. So here this negative value need to be flipped upward. So if you take the mirror image, then this will be like this. So this will be drawn like this. So that's what simple. So this is how the thing it will look like. So this will be t as it is. So this will be t. This will be y of t. Y of t which will be equal to modulus of x of t. Okay guys, so this is what the difference. So here if you see the only the parts which are below the horizontal axis will be taken into the mirror image. The above parts will be kept as it is. So here the y of t is modulus of thing. So then the last operation, which is nothing but add or subtraction of DC to the signal. So this will be the last thing. So this will be quite simple. So just the uplift and downlift of the thing. So add or subtract of DC signal or DC value. Okay. So DC value means nothing but a constant value. Okay. So here the x of t over the t will be given. So as it is we dealt for 3 operations. So if they asked us to add the signal, then this will be x of t plus a over the t. If they ask us to subtract, then x of t minus a versus t. Okay. So this will be shifted upward. So general operation is that this will be shift up. So just the graph will be like a lift we going to second floor, right? Similar to that, this will be shifted up by a. So this will be shifted down with respect to a. So we are coming from second floor to first floor. So shift down by a. Okay. So these are this is very simple operations. So I will explain even this with the graph so that you guys can able to understand it. Okay. So let me draw it. The first thing I'm taking to going to take the same triangular pulse. Here also I'm drawing the triangle pulse first it is. Then I will explain the things. Okay. So here this is over the time period t and this is x of t. Here the value is 2. Here it is starting from -2 and it is 2. Means this is starting from the slope 0. It's going to 1. Here the slope is 1. Here the slope is -1 and it is again going to 0. Okay. So this is how the signal is tracing the boundary. Then it is going up and down again tracing the boundary. Okay. So here if we have to do the x of t, then what will be the operation is that here we are going to find out the y of t, right? So y of t which is equal to, let me take the example y of t which is equal to x of t minus 1. So now what we have to do, we have to shift the signal downwards. So I am going to shift the signal. So how we can shift is that, so general shifting. So this will be coming downwards, right? That's it. Okay. I'm making this easy as general thing. This is how it will work. So here if you see, the value shifted onwards down. So that is how. Okay, the same value minus 2, 2, this value became 1. Okay, so this is what the difference. So here it will be minus 1. So it will be at a 0, then here it will go as a slope 1, everything will be same, but just the value of reference will change. Okay, so this is the guys. So you guys able to understand the things, right? So this is very easy. So this is how you'll be doing. So here now I'm going to give you one homework sum so that you guys can able to master the things. So here how we can solve the difference thing is that I'm going to give one little bit complex signal and I will ask you to do different operations. All the 4 operations that we see, right? So I will make you to do that one. So let me, sorry. So let me, so this is any random signal. So here the values are tracing from minus 3, minus 1. So this is minus 2, minus 2, minus 1, plus 1, 2. And over the time period t, this value is 8. Okay, so this is x of t. So you have to draw the diagram y of t which is equal to modulus of 2x of t modulus of minus 2. Okay guys, so this is a homework for you guys, not homework, let's solve this in this class itself. So please pause the video and try to answer it. So I will give you few steps how to solve this one. So first thing is that you multiply the signal. So you guys please multiply the signal and then get the take the modulus for that. Okay, after that you guys can add the signal with respect to thing. So this is how you guys can able to solve this problem. So first thing is that please multiply the signal. So the vertical axis are the real thing, so please multiply that with the 2 and then take the modulus and then again subtract the thing with the help of the value, the DC value, that is equal to minus 2. Okay, so this is how you can easily achieve it. So let me draw it so that you guys can able to understand it. So you guys also pause the video and try to find the answer. So first let me draw the two things. So I am going to solve this in a two way. So first thing I am going to multiply with the 2 and going to take the modulus. Okay, so if you take the modulus, this value will be shifted upward, right? So I'm going to do that one first. So this value will be shifted upward and it will come like this. And again the positive value above value will be the as it is, right? So this will be straight 90-degree curve and this will trace like this. Okay, this is straight, just a mirror image. So that's it. So here then values will be as it is. So minus 2, minus 1. So 1, 2, t. So this value is that. So here we have multiplied with 2. So here if the value is here, if I put the value is minus 1, then this value which is equal to 16. So this value which is equal to 2. Okay. So here we have took the modulus. So here what is the difference is that. So this graph is 2 x of t. So this is what the value of the thing. Okay. So this is how this will be changed. So here another one thing we have to do, we have to downshift this with the 2. Okay, so if we downshift this 2, so then what will happen is that, so let me write that here. Even we can shift that, but I am writing this here like this. Okay, so same value here, the value is 2, so this will be starting to 0. So this will trace like this. Sorry. So this will trace the boundary, it will hit the 0 and it will come down 270 and it will go above and it will again come down. It will sharply go up and again it will go down. We have to extend this because we here also we have to extend this. So don't forget to do this one. So this is also very important. So here thing itself will come like this and it will go. So it will be 0. So this will be 14 because 16 minus 2 is 14. So this is how this will be. So this will be minus 2, minus 1. This will be 1 and this will be 2. So this will be 2 and this will be 1. Okay. So this dipping part which is equal to 2 and the part which is going upright. So this value is equal to 1. Okay. So this value is 1. Okay. So this is how we can draw it. So this value is nothing but to x of t mod minus 2. So this is y of t. Okay, so here if you see, we have done amplitude scaling, we have done modulus, we have subtracted a DC value. So all the operations that we have dealt so far, I have completed in the single graph. So this is how we need to practice the question. So if we signals and systems is nothing but just a mathematical. If you guys have a good mathematical understanding, then this will be very easy. It will be very even we can say this will be that much easy subject. Once you guys can able to understand it conceptually, then you guys can love this subject, guys. So that's what I have to say here. So please like, share and subscribe the channel so that you guys will be notified on all of my lecture. So next class we'll be starting with the operations on the independent variable. That will be quite more interesting than this one. So there we will be seeing time shifting, time scaling, those kind of operation will be there, time reversal. So far we have done with the what we have done with the dependent variable, that is x with the whole signal that is in y-axis. Next we will be completely going to do with x-axis, means the time side. So time side, the independent variable is t, right? So that operation we will be doing, that will be more challenging and that will be more interesting. So stay tuned guys, like, share and subscribe the channel, motivate me to post more videos like this so that I will be doing this continuously. Thank you guys, stay tuned, bye.